Okay, students, so we're here today and we're going to be talking about the distance formula. And we're going to be talking about the distance formula and how to find the lengths of slanted lines for 2 days. And it's action-packed. We use the distance formula throughout geometry. So this is a big punchline. All right, before I just give you the formula and say memorize it, well, let's try to understand where it comes from, how it works, all that fun stuff. So we got just a quadrant right here. I'm going to draw 2 random points. Right here looks like a good one. I'm going to call that A. And over here looks like a good place for B. All right, now let's talk about this. How do we find the length of AB? It's a slanted line. In a coordinate plane, you cannot find the lengths of slanted lines simply by counting. All right, so draw 2 points A and B. Check. Form a line segment AB. Check. Make a right triangle. Use purple. All right. Perfect. All right. And remember, in math, I can't be certain that this is a right angle until I see that little box. All right. And I got a little excited. Let's rewind a little bit. Let's call B x sub 1, y sub 1. I can call it whatever I want. And A will be x sub 2, y sub 2. All right, those are arbitrary points. They're just random points, any real points you can think about. All right, now let's find, all right, so think about the length of each leg in the right triangle. Let's think. I see the gears turning in your guys' head. Good job. You guys are so smart. Now we're going to write an expression for the length of each leg. So like this right here, what I just highlighted. If we want the length of this leg, well, we need the, let's see, this is the horizontal leg, so we need the horizontal distance. So we're going to take the x's and we're just going to find the difference. All right, it'd be x sub 1 minus x sub 2. All right, now this is very arbitrary. We're just using random points, but you just find the difference and that's the length of that leg. Similarly, we got this pink leg right here. This is a vertical one, so we're going to look at the y points because the y-axis goes vertical. And this would be y sub 1 minus y sub 2. All right? So we wrote an expression for each leg. Now, something we're going to go in depth, super in depth in tomorrow's lesson is we're going to name these things. I'm going to call this side A, this side B, and I'm going to call this side C. Label each side. Okay, I did. Now think about Pythagorean theorem. I know you guys have heard of Pythagorean theorem before. How much experience you have with it probably varies, but I know you guys have learned it at some point. We all know that for right triangles, a squared plus b squared equals c squared. Actually, let me write it backwards. Let me write c squared first. C squared equals a squared plus b squared. Well, if, actually, time out, pull another fast one on you. I'm going to switch what I called A and B. Call that A, call that B, silly me. All right, well, A, this side A right here, the right triangle, I called x sub 1 minus x sub 2. So I'm going to plug that in right there, x sub 1 minus x sub 2 squared. Plug that in for A. I'm going to do the same thing for my good friend B over here. That side is y sub 1 minus y sub 2. Squared. All right, now overall, C, what is C? C is a segment AB. And what's the length? So I'm just going to say AB squared because I want the length of AB is now equal to all this junk. All right, all I did was substitute things in. And then all I do is take the square root of both sides, and boom, now I have AB solved for. Some random line segment in a coordinate plane all I have to do to find the length of that is take the square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. Boom, that's it. That's the distance formula. Here's Pythagoras right here. He's so happy. Let's draw a smiley face on him. Look how happy he is. Yay! All right, so the distance formula is just Pythagorean theorem, but it's on steroids. All right, and just for repetition, we're gonna write this down a bunch of times. We're gonna write it down here, and I'm gonna do something. Notice how up here it's x sub 1 minus x sub 2. I'm gonna swap the order. Just as long as we keep the x's together and the y's together, order doesn't matter. All right, consistency does. X's and y's have to stay together, but overall the order doesn't. Order don't matter. All right, and then just again, this is optional. I won't force you to do this, but if you want to write it down, I can write it as x sub 1 minus x sub 2 squared. The reason why the order doesn't matter is because we're squaring. So no matter if you have a positive or negative, once you square it, it's going to spit out a positive number, which makes sense. All lengths, all distances have to be positive. I don't know about you guys, but I never measured something and got a negative length. That would be freaky. All right, so are you ever going to have to replicate this? No. This is just for your knowledge, just so you can see where the distance formula comes from, derive it, appreciate it. That's really just Pythagorean theorem. But on coordinate plane, using Pythagorean theorem might not be too easy. We might actually just want to use the distance formula. All right, stay tuned. Watch the next video to see us actually use the distance formula.